Welcome, America. Welcome, Taylor Swift, to the Friday edition of Pre-Calculus. We are filming live today in Studio 212. Welcome. Today we're going to do some more trig identities, and we're going to start with the worksheet that is hopefully attached. We're going to go from problem 1 to problem number 3. So these are just like last class, but they're just a little bit more complicated. Some of them are pretty tough, and some of them have lots of steps. And like I said last time, sometimes you might be starting something and you might start one way and then it might not work to get to the other side, and you might have to erase everything and try something else. I have done that many times, and it is perfectly okay to do that. So I'm going to try and walk you through these problems, obviously the easiest way possible. Because that is what we're trying to do. We're trying to be efficient. So anytime you can use a Pythagorean identity, it's definitely going to save you a lot of time and a lot of steps. This looks really familiar, looks really similar to one of the Pythagorean identities. 1 plus tangent squared equals secant squared. I'll write it up here. 1 plus the tangent squared equals secant squared. Now, this says secant squared minus 1. So I'm going to have to manipulate this Pythagorean identity to get it to look like secant squared minus 1. But all I have to do is subtract 1 from both sides. So I'll just start with that. Now I can see that the secant squared minus 1 equals the tangent squared. So I'm just going to substitute tangent squared in. Drew, where's your sheet? For secant squared minus 1. Is everybody good with the first step? I'm going to put my equals on the right side since I chose to start on the left side, to work on the left side. Now I'm going to rewrite the tangent as sine over cosine, but that's the tangent squared. So it'll be sine squared over cosine squared. And I'm going to run out of room. That's okay. I hate writing over other stuff, but whatever. There's your numerator. That's tangent squared. The denominator is secant squared. Secant is the reciprocal of cosine. So that's 1 over cosine squared. Any questions so far? I rewrote tangent squared as sine squared over cosine squared. And I rewrote secant squared as 1 over cosine squared. Now, keep, change, flip. Are we good? I see eyes that are still processing. Are there questions on what I did? No questions on what I did? Okay, so now I need to keep, change, flip. This is really hard to see. I'm gonna draw an arrow and start over here. Okay, so I'm gonna keep, change, flip, and just, you don't have to go through writing all of this if you can do this in your head, but since, you know, it's easier for me to just write the steps out, just so if anyone has any questions, you can see it visually. Keep, change the division to multiplication, and flip cosine squared over 1 to 1 over cosine squared to cosine squared of x over 1. Now you can see that those cosines are going to cancel. Now I forgot the equal sign here. Got to make sure I put that to show I'm working on the left side. And here's an equal sign as well. And this simplifies to sine squared, which is what we are looking for on the right anyway. So I can finish it off by writing sine squared x. Check. Verified. How are we doing? So we used a Pythagorean identity. Then we used reciprocals. We used keep, change, flip. We used, what else do we do? Canceled, factors. There's a lot going on in these problems, and they get more complicated. Yay! Anyone ready to go to number 3? Oh my gosh, was that a yes?
Yes.
I'm ready to go to number 3, or did you just finish it and you know?
No, I'm ready to go to number 3.
Yes, I love it. This is definitely putting me in a better mood. This class is putting me in a better mood. All right, America, sorry, I was grumpy before this class started, not gonna lie. All right. Can I delete this? Are we still writing this down? Okay, yes. Love the energy. Number 3. What do you guys, does anyone notice anything about number 3?
Parentheses.
Okay, what's inside the parentheses? What does it look like? Yeah.
Cosine squared.
Yes, because the sine squared of x plus the cosine squared of x equals 1. So if I subtract sine squared from both sides, I'm going to get 1 minus sine squared equals cosine squared. So I'm going to substitute in for this parentheses. I can write cosecant of x. Cosecant squared, and then times, and I'll keep it in parentheses, it doesn't really matter, cosine squared. I could have just put times cosine squared, but whatever, I left it in the parentheses. Now what? Yes, so cosecant is 1 over sine squared times cosine squared. And that's like over 1, right? I don't put it, but it's there. So this is cosine squared over sine squared, which is equal to cotangent squared. Look at that. Check. Oh, I'm at 7 minutes. Any questions before I? Okay.